You just bought a mobile proxy and the provider handed you one cryptic line, a host, a port, a username, and a password. But then somewhere in the dashboard you spot a second option called IP allow listing, and nobody explains when you would use it instead. This is the video that fixes that. I am going to show you exactly how no password auth works and when it is the better choice. The password IP, FenTimP, real phones, real SIM cards from Singtel, M1, and StarHub. So I set up these exact connections every day, and IP allow listing is one of those things that looks fiddly until someone shows you the shape of it. Once you see it, you will reach for it on every server you own. Let me start with the two ways to authenticate, because allow listing only makes sense next to the other one. The first way is a username and password. You paste both into your tool along with the host and port, and the gateway checks them on every connection. This works from anywhere, on any network, which is why it is the default. It is the right pick when you move around, when you connect from a laptop, or when your address keeps changing. The second way is IP allow listing, which some people call whitelisting. Instead of proving who you are with the password, you prove it with where you are connecting from. You register your server's public address with the provider once, and from then on that server connects with no user and no pass at all because the gateway already trusts the source IP. Think of it as the difference between a key and a guest list. A password is a key. Anyone holding it gets in, no matter where they stand. An allow list is a guest list at the door. It does not care what key you hold, it cares whether your address is on the list. Those are two genuinely different models of trust, and each one fits a different situations. So why would you ever drop the password and trust an address instead? The honest answer is that credentials are the thing that leaks. A username and password sitting in a config file, or hard-coded in a script, or pushed to a Git repo by accident, is a secret you have to protect forever. With allow listing, there is nothing in your code to leak in the first place. The auth lives in the provider's dashboard, not in your source. That is the real reason it wins for servers and automation. A scraper running on a fixed box does not move around, so it does not need portable credentials. It needs to be clean. No secret in the environment, no secret in the repo, nothing to rotate when an intern leaves. The box connects, the gateway recognizes the address, and the traffic flows. It is genuinely simpler once it is set up. There is a second quiet benefit people forget. When the password is gone, your connection string stops being sensitive. You can log it, you can paste it into a ticket, you can share it with a teammate debugging the box, and none of that exposes anything because the string is just the host and the port. The thing that actually grants access is the address you are coming from, and that lives safely on the provider side. Here is how it works end to end. You find your server's real outbound IP, you paste that IP into the allow list in your provider dashboard, and you save. Then on the server itself, you connect with just the host and the port. No user, no pass in the connection string at all. The gateway sees the request arrive from an address it already trusts, and it lets the traffic straight through. Now the step everyone gets slightly wrong, finding your server's real outbound IP. The address you want is not the one your server thinks it has on its own network card. It is the public address the rest of the internet sees when your server reaches out. The cleanest way to find it is to ask a neutral endpoint from the server itself. You run one small command on the box that hits a service which simply echoes your IP back, and whatever comes back is the address you allow list. A concrete way to do that is to open an SSH session into the server and run a single curl to a service that returns your IP as plain text. Whatever it prints is your true outbound address. Do not guess it from your hosting panel, and do not copy it from the network settings inside the machine, because those often show a private address that the public internet never sees. Run that check from the exact machine that will use the proxy, not from your laptop, because they almost certainly have different outbound addresses. The classic mistake is to find your IP at home, allow list that, and then wonder why the server in the cloud still gets refused. The server has its own address, and that is the only one that matters here. If your server lives behind a NAT gateway, which is normal in cloud setups, the address you get back is the gateway's address, and that is the correct one to allow list. Every box behind that gateway shares it, so even if you have 10 machines in a private subnet, you usually only allow list the one public address they all leave through, not 10 separate entries. Now the big gotcha, and this is the one that quietly breaks people. Allow listing only works if your server's outbound IP is stable. If that address is dynamic, it will change on its own schedule. Your old entry stops matching and access dies. The worst part is how it fails. The proxy looks broken, your scraper starts getting refused, and nothing actually changed in your code. The address moved out from under you. This is exactly why allow listing is a quiet trap on a home connection. A typical home ISP hands you a dynamic address that can rotate after a reboot, a line drop, or just overnight on the provider's own schedule. You set everything up, it works perfectly for a day, and then one morning every request is refused for no visible reason. The fix is not in your code, it is that your IP changed. So allow listing works best on a static IP or a VPS where the public address is fixed and yours for the life of the box. When you rent a VPS, that address is generally stable until you destroy the machine, which makes it an ideal home for an allow listed scraper. If you are on a cheap dynamic plan instead, expect the address to rotate and expect allow listing to break with it. That is not the provider's fault and it is not a bug. It is just what a dynamic IP does. Two more caveats live in the same area. The first is NAT. If a whole office or a whole cloud subnet sits behind one outbound address, then everything behind that address shares the same allow list entry. Which brings me to the security point in a second. The second is shared IP. On budget hosting, you sometimes share a public address with other customers, and you cannot safely allow list an address you do not control alone. That shared IP case deserves a hard rule. If you do not control every machine sitting behind an address, do not allow list it. You have no idea who else lives through that same IP, and the gateway cannot tell them apart from you. On the cheapest shared hosting, you genuinely cannot know, so on those boxes you are better off staying with a username and password and skipping the allow list entirely. Here is something people miss. You do not have to choose one method forever. Most providers, mine included, let you mix them. You can allow list your production servers so they run clean with no credentials and still keep a username and password for your laptop so you can test from anywhere. The two methods coexist on the same account. Use the address-based one where the address is stable and use the password where it is not. A practical pattern from my own fleet looks like this. The production scrapers all leave through one static address, and that single address is allow listed, so none of them carry a secret. My own laptop, which moves between home and the office and the occasional cafe, just uses a username and password. Same account, two methods, each one matched to whether the address is fixed or roaming. You do not have to commit to one religion. Now the security trade-off, said plainly, because allow listing is not free of risk. When you trust an IP, you trust everything connecting from that IP. If anyone else is on the same address through a shared box, a shared NAT, or a server you did not lock down, they can use your proxy too, and the gateway will happily let them, because as far as it knows they are you, so lock the box down. Treat an allow listed server as a key, because that is exactly what it has become. Keep it patched so it does not get taken over. Put a firewall in front of it so only the ports you need are open. Lock SSH down to known keys or addresses only. The moment that machine is compromised, your proxy access is compromised with it, and there is no password the attacker even needs to steal. There is one more habit worth building. Keep a short note of which servers you have allow listed and why, because allow lists rot. 6 months later, you will have an entry pointing at a box you decommissioned and an old address that maybe belongs to someone else now. Every so often, read the list, match each entry to a machine you still run, and delete anything you cannot account for. Then verify, because you should never assume Auth works. From the allow listed server, run one curl through the proxy to a neutral endpoint that reports your IP. If it comes back with a Singapore address on Singtel, M1, or StarHub, your allow list is live and the box is trusted. If it comes back refused, your outbound IP is not the one you registered, and 9 times out of 10, that is the dynamic IP gotcha biting you. Check the real outbound address again and compare. When you verify, read the result properly rather than just checking that something came back. A refused or forbidden response means the gateway did not recognize your address, so the fix is on the allow list side. A connection that simply times out means the gateway is not reachable from your network at all, which is a firewall or routing problem and a completely different thing. Telling those two apart saves you an hour of chasing the wrong fix. So here is the whole thing in one breath. 2 ways to authenticate: password or allow list. Allow listing trades a portable secret for a trusted address, which keeps credentials out of your code and is cleaner for servers and automation. Find your server's real outbound IP from the box itself, register it, then connect with just host and port. It works best on a static IP or a VPS. Watch for NAT and shared addresses. You can mix methods, and you must lock the box down because the IP is now the key. If you want to run this on a real Singapore connection, there is a free trial of Singapore Mobile Proxy, real SG Mobile EPS, sticky sessions, and DNS that routes through the tunnel, all from my own farm. Grab the trial at singaporemobileproxy.com/client/trial and use code YT30 for a discount on your first month. The link is in the description and it points to the homepage so you can start there. If this made allow listing click, subscribe, because I post 2 new videos every weekday that go 1 level deeper into running proxies properly. Thanks for watching, and I will see you in the next one.